I'm Meredith. I'm a dietitian. And like to say, I'm super excited about sharing this pathway with everyone. My daughter suffered pretty miserably the past few years because of plantain flour. We thought that plantain flour was a low oxalate food because we had a bad handout that was based on data from about 40 years ago. And so since then, our environment has been continuously accumulating glyphosate, and glyphosate in a plant is turned into oxalate. So our plants that we're eating now are way higher in oxalate than they used to be. So that handout was just wrong. I don't think it was intentional. But what happened was my daughter ended up finally being poisoned with when I made muffins, and she just was vomiting and vomiting. And I took her to the emergency room. They couldn't figure out what was going on. They populated the labs to the portal after we left, and I saw that there were crystals in her urine. And I thought, what in the heck did I change this week? And the only thing is I had made plantain muffins with bananas, and that's it. Bananas aren't high in oxalate, but apparently that plantain flour, it turns out instead of 1 milligram per cup, it has up to 525 milligrams per cup. And so my daughter was poisoned. And then that made me realize over the past 10 years, she's had this plantain flour on and off. And over the past 2 years, I've been adding it to her bread. And so she'd been getting increasing quantities of oxalate over the past 2 years. And so I'm going to explain to you what that did to her. And basically what it did is it made her have very high levels of retinol, which is a type of vitamin A that's in the blood. So let me start with this. There is actually two sources of vitamin A in our diet. First, there's beta-carotene, and that comes from plants. Those are our things like carrots and sweet potatoes. And it's also in green vegetables too. So beta-carotene is something that we consume from plants. We can also get other carotenoids from plants like lutein. But lutein wouldn't be metabolized to the active form of vitamin A in the body. So anyway, so there's these carotenoids. We get these. They actually enter into metabolism at this area right here. We call this retinal or retinal aldehyde. And so we think of retinol as like our eyes, right? Like in our retina. And that's supposed to be involved in the visual cascade. And then in our diet, we also have vitamin A in the form of retinol. So this could alcohol form. And we can take retinol from our diet and we can store it inside of our liver. And then when we need it, our liver can empty retinol back into the blood. And we carry this retinol on something called retinal binding protein. And it's actually a retinal binding protein is actually complexed with our thyroid hormone, and it's called transthyretin. So it's basically a storage molecule in our blood where we have vitamin A and thyroid hormone, so that when our body needs these nutrients, we can take them from this carrier protein. In a separate video, I'll talk about what you might expect to see on a lab value related to your thyroid if you have very high vitamin A. Typically, just to sum it up, you're going to see that your thyroid hormone is going to be suppressed. Your TSH will be suppressed. It'll look like you're hypothyroid, and you possibly will be. And that's because your total volume of vitamin A has gone up, and with it, you're binding more thyroid with the vitamin A. So basically, we can move this vitamin A into our liver, out of our liver, and then we can metabolize it to retinol to retinal aldehyde using alcohol dehydrogenase. And there's other enzymes that do this too. So there's some specific to vitamin A, but in general, alcohol dehydrogenase is a big one that we use. And then from retinal to retinoic acid with a retinal aldehyde dehydrogenase. But again, you can also use just aldehyde dehydrogenase. And these are enzymes that are also used in alcohol metabolism. And we find that people who have bad alcohol habits, they typically look like they have vitamin A deficiency. They'll have skin disorders and they look really sick. And sometimes it's because they're not making retinoic acid, because they're tying up these enzymes in metabolizing alcohol. So also, people who drink more alcohol technically usually have vitamin deficiencies, and so that comes into play too with getting the retinol out of the liver. Okay, so the only way we can get retinoic acid out of our body, or vitamin A out of our body, is in the form of retinoic acid. And so once it gets to this form, we can metabolize it with a cytochrome P450 enzyme called CYP26. And this requires energy in the form of NADPH. So it's not shown on this diagram, but I was in a hurry to make this video because I have a lot of people asking me questions and I felt like I needed to talk about it. So you can metabolize it with this cytochrome P450 enzyme with NADPH, which you actually can make from this molecule over here, which is NAD. So these are called cofactors, and cofactors help us to run energy reactions. And then after you metabolize it here, then you actually have, you take these metabolites and they go through another pathway that isn't shown here either. And it's called glucuronidation. And so it's basically like attaching a glucose molecule, and then you can excrete these through your liver, through your bile. So having a very healthy bile flow is important. Like if you have a thing called cholestasis and you're not able to move things out of your liver and make adequate bile acid, then you could potentially be building up these metabolites. So now let's talk about what happens when we consume oxalate. And I thought at first it was only happening in my husband and my daughter. And I thought that this was actually them having a form of hyperoxaluria, because there's like these genetic things that can happen where you produce too much oxalate in your body. It's still possible that that's going on. We're seeing metabolic genetics, but what I'm noticing is that this is happening in many people. And I don't think we all have bad genes. So let's talk about what dietary oxalate can do. So if we eat dietary oxalate, it comes down here, and you can actually make oxalate from vitamin C in excess. And with vitamin C, it just degrades directly to oxalate. There's no enzymes involved. If you eat a lot of vitamin C, you're going to make oxalate, and you're going to absorb that, and it's going to go into your body and wreak some havoc. You can also make oxalate from glycine, but this only happens typically in a thiamine and B6, or either one, thiamine or B6 deficiency. So you might see this though if somebody's been consuming oxalate for a long time. When you pee out the oxalate, you do lose some of your B vitamins. There's other ways to lose these B vitamins. For example, if you take Lasix, that depletes thiamine. That formin is known to deplete thiamine. B6 is depleted when you take a birth control. Also, seizure medications deplete B6. So there's lots of ways that we can mess up our ability to use this amino acid called glycine in our body, and it can become oxalate. There's also other medications that can become oxalate in the body. For example, Miralax is polyethylene glycol and actually enters this pathway that ends up making oxalate. And then melatonin, it also interferes with your ability to make vitamin A and retinol aldehyde. Take retinol and retinol aldehyde and convert them to retinoic acid. And I'll do separate videos on those. Okay, so oxalate directly impairs this enzyme called lactate dehydrogenase that's in the body. So interestingly, this enzyme, lactate dehydrogenase, LDH, is the last enzyme in the making of oxalate in the body. And so our bodies are super smart, and they want to stop us from making too much oxalate if we already have oxalate in there. And so it's a feedback mechanism. So it shuts off this enzyme, and because this enzyme is shut off, then you can't take the energy that you eat, which is like carbohydrates or fats, and even a little bit of amino acids. You can't take them from the state of this thing called pyruvate down to lactate. You might recognize lactate. Everybody's like, ooh, lactate. It's good to have low lactate because you don't want lactic acidosis. But that is wrong, because lactate is acting like a fulcrum in metabolism, and it tells our bodies to switch between using glucose as energy and fat as energy. And so someone who has very low lactate levels will feel extremely tired, and They'll also probably have a tiny bit of ketones, but not enough to be in ketosis. And then also when your lactate is low, you tend to hold on to fat more. You just don't have the energy to be able to burn fat in that energy, or sorry, I should say cofactor. You don't have enough NAD to be able to drive this thing called the Krebs cycle forward, which is how you use up the energy that you eat. So what you end up doing is converting all of the food that you're eating into fat. So people who have oxalate problems typically start to gain weight over time. I also think that is related to their need to export vitamin A from the liver into the fat cells. Okay, so you impair this lactate dehydrogenase, and what happens is you stop being able to go from this cofactor over here, NADH plus H, to NAD. And when NAD levels are really, really low, then you can't drive these reactions that metabolize vitamin A forward. And so what you end up with is a retinoic acid deficiency. So you'll have all or some of the symptoms of vitamin A deficiency, such as you'll have keratosis pilaris, which is where you get little like chicken bumps on your skin, or you may have like crusty heels or crusty elbows, or losing your hair, or dry lips that blister, or sometimes they blister maybe, and sometimes they're just cracked, or trying to think of any more. Impaired wound healing, or problems with your immune system. And so it seems like you would have a vitamin A deficiency, and then you might take vitamin A because the doctor would say, oh, you must be low on vitamin A. But in reality, you're very high on vitamin A, but because you have this oxalate in your diet, you're not making the active form of vitamin A anymore. That's crazy, right? And so you don't want to feed a system that's broken. And so what I've realized over time, and I'll make another video about this, is that it's really not just oxalate that's doing this. It's anything that disrupts your ability to make this cofactor, NAD. And there's lots of different things that I've figured out as I've seen multiple clients over time go through this. They have this disruption in different ways. So it's important to find what you have disrupted. It might be oxalate, but it also might be something else. It could be thiamine deficiency. It could be a B6 deficiency. For me, it was over-exercising. And so there's lots of different ways that we can cause problems right here with this cofactor. Okay, so this video is a little bit long, so I understand, like, if you're kind of burnt out, just pause it, but I'm going to keep going. So here's what happens as you stop being able to move all these vitamin A sources into retinoic acid. The vitamin A starts to build up, and then you fill up the stores in the liver. And once the liver stores are full, your body goes into protection mode to protect you from retinol, because it is an alcohol. So what it does is it takes the retinol and it packages it into fat. And so what you might see in your lab values is that all of a sudden, out of nowhere, you start to have high cholesterol and high triglycerides. Usually it starts with high cholesterol, and that's because your body takes the vitamin A, packages it into fat, puts it into your cholesterol, into VLDL, sends it out, and all of your vitamin A starts to get stored inside your subcutaneous fat cells. So you have that going on, and then because the other way your body, remember, it uses retinol binding protein, puts it on retinol binding protein right here, and as that goes up, your fat cells also make like a retinol binding protein, and that retinol binding protein causes insulin resistance. So then you go from high cholesterol to high triglycerides because you can't actually get the triglycerides into your cells anymore because you're insulin resistant. So you see your lab work blowing up, and you keep trying to eat healthy, and you can eat more spinach smoothies, and you try to eat more things with fiber and lots of sweet potatoes, and you perpetuate the problem. It gets worse and worse as you consume more and more oxalate. So another thing that happens is as soon as you stop, or as maybe not as soon, but when you stop making enough retinoic acid, then your body your retinoic acid actually regulates a hormone called hepcidin. And hepcidin actually tells your body to stop absorbing iron. Okay, so this pathway, if it's broken, it could actually cause iron deficiency anemia. However, it is possible to start with iron deficiency anemia as well. So let's just assume, though, that this person started with eating too many oxalates, and now all of a sudden their hepcidin levels go up because they don't have enough retinoic acid to control this hormone. And what happens is in their intestines, the iron gets stuck in their intestines because hepcidin basically tells the intestines don't absorb any more iron. The iron levels go down really low, and then that goes up and it affects the ability for an individual to get the vitamin A out of their liver. In iron deficiency, vitamin A gets locked into the liver. And so you have another problem where the liver can become toxic. And then the other thing that you have going on, like I said, you could also start with an iron deficiency, which makes it hard for you to mobilize the vitamin A out of your liver, and it sets you up for liver problems. There's one more thing I was going to say. So if you have very, very high retinol levels in the blood, that actually triggers a histamine reaction. Okay, so like, let's say you have a lot of allergies. Your skin is really itchy. You sneeze all the time. Possibly like you have dermatographia where you scratch and you get little bumps everywhere. And as your retinol levels go up, your histamine reaction goes up too. Okay, another problem with high retinol in the blood is that it triggers the parathyroid hormone to release it triggers the parathyroid gland to release parathyroid hormone. And so what that ends up doing is triggering you to dump calcium from your bones. So a lot of people will think that, and it's true, you could be peeing out some oxalate, but a lot of people think that what they see, that cloudy urine, is oxalates, but in actuality, it's calcium just dumping out of your bones. And that's why your bones hurt and your teeth hurt and you ache all over. It's because you're just killing your bones with your very, very high retinol levels in your blood. And so there's some ways to combat that, and that's something for another video, but I just wanted to describe the symptoms of chronic oxalate issues. At first, you get your symptoms of peeing out oxalates from the oxalates that you eat. But once you lower your dietary oxalate level, the cloudiness in your urine and your symptoms, I do not think it's all related to oxalate dumping. I mean, you do metabolize some of it out of your body, like if you were to have like little crystals somewhere. But really, I think the majority of the problem here is now that you have this crazy thing going on with retinol and it's destroying your bones and you have no idea it is until all of a sudden you get cavities or you start to know that you have osteoporosis. So that's something interesting, I think. Okay, so now let's talk about this in relation to neurodegenerative disease and autism, because that's something that I'm super interested in because my own daughter has autism. So let's say she's not making retinoic acid. The only step that she can really get to in her body is retinol aldehyde or retinol. Depending on her NAD levels or NAD levels, she basically fluctuates between being drunk on retinol and aldehydes. So she's either that, or she's making a small amount of retinoic acid or a lot of retinoic acid. So say I restore all this NAD and everything moves forward really, really fast. Sometimes she has symptoms of poisoning. And a lot of times that's attributed to oxalates coming out of your skin from somewhere or from your joints. But I actually think that this is retinoic acid poisoning. And so what happens on a bad day where I've like really pushed this pathway and she's producing way too much retinoic acid, she'll get blisters on her lips. I have one friend who broke out in a rash on her body because she's basically just turning over, I guess, her skin really fast. One friend looks like she had like retinoic acid burn. Her skin turned bright red. Let's see, headaches, nausea. These are all things that are related to a really high level of retinoic acid. And then if you have really healthy cytochrome P450 enzymes that aren't impaired and you have CYP26, it can metabolize that away. And so the symptoms start to go away. But one problem that I see in this is that what people do to treat the oxalate dumping is they go ahead and eat more oxalate. That actually works. The reason why it works is because what you do is you impair lactate dehydrogenase, and then your NAD levels go low again, and then you stop making retinoic acid. But what you're ending up doing over time is causing yourself to go higher and higher in vitamin A. So we have to find a way to increase the breakdown of retinoic acid so that we're not having to go back and eat the poison that's causing the problem. And so there is a way to do this, and I'll kind of work it out in future videos. And it will be just general recommendations because I'm not your dietitian. I'm just a dietitian, and I don't know your health history. I'm not your doctor. And so I really recommend whatever I say here, you run it by your own personal doctor. So back to the people who have degenerative brain disease and autism. So they're kind of fluctuating between making some retinoic acid and then being basically drunk on metabolites in their body, because it's not really necessarily the vitamin A and the retinol aldehyde that they're drunk on. What they are drunk on is the metabolites that we make during metabolism. So every time we use a fat as energy, it has an alcohol backbone. And if we can't metabolize that using these enzymes that are in our body that kind of do multiple things, then we end up feeling drunk. So in somebody who has autism, it might look like giddiness followed by raging anger. So a lot of the behaviors that happen, like the screaming and stuff, that might actually be these fluctuations between these two states of being drunk and not being drunk. So that's pretty neat. Since I've tried to fix this pathway, my daughter, her behaviors are so much easier to deal with. She'll do like the raging thing, but she does it calm. So instead of like a big rage, she'll cover her ears and just go, It's actually kind of adorable because she still has the behavior, but she doesn't have the mood behind the behavior. So that's pretty funny. So kind of related to that, I was talking about like the symptoms of vitamin A toxicity. One of them is you like get your fingertips start to get really crusty and hard, and the skin feels weird, and it almost like you have the urge to pick at them. And so, yeah, my daughter will pick, and she rips toenails off because her fingers are so uncomfortable. And also my husband suffers from this problem too. I caught him picking his fingers and I said, why do you do that? And he's like, it just feels weird. And I go, but we tell Zoe not to. And he's like, yeah, but I can do what I want. So also he doesn't go as far to rip his fingernails and toenails off, where she can't feel her fingertips very well. So she'll just go ahead and do it. So, okay. So then they have this really high retinol level. And then this retinol gets inside of the brain. This is my theory, my hypothesis. And basically, there's evidence in literature to show that retinol can combine with this thing called ethanolamine, which is needed to make ether lipids in the brain. And ether lipids make our brains work well. It helps our autonomic nervous system to work. So digestion is dependent on ether lipids. And so when our vitamin A levels are too high in the form of retinol, then we get this complex between retinol and ethanolamine, and it makes this thing called A2E, which is a Schiff base. It's not supposed to be in our body. That aggravates microglial cells. Microglial cells start to release inflammatory cytokines in response to this, basically like a plaque in the brain. And then you get neurodegeneration. And so we know when people who have Alzheimer's disease and they have autism, we know that on blood work, they have low ethanolamine levels. And so this might be it. This might be the way to help people who have Alzheimer's disease and autism. We could potentially monitor their lab values and see if they have high vitamin A. But even if they don't have high serum vitamin A, what are they doing with their vitamin A, right? So if we can help people to start to metabolize vitamin A, we could potentially stop this epidemic of Alzheimer's disease and autism. And also, I saw a really cool article, and I'll do a separate video on that one. I saw a really cool article showing that that when we take prenatal vitamins in pregnancy, for some reason, the beta-carotene in the prenatal vitamin doesn't even show up. It's not even there. And they can't find it in the baby. They can't find it. I'm saying they can't find it in the baby's fat cells afterwards. And it's because the fat cells are the last thing to develop in a baby. So they're not storing retinol from beta-carotene. They're not storing retinol from beta-carotene in their fat cells. They're storing it in their nervous system. That's what I think. And so that's causing this A2E to happen even before our babies are born. So this is crazy. And I'm just so thankful. I mean, I wasn't thankful that my daughter got poisoned and that she's unhealthy and she has vitamin A toxicity and kidney issues and was just peeing out her calcium and getting cavities and was sick for like 2 years, and it culminated in this like crazy thing. But I am so thankful because I think this is it, and I want Zoe to have purpose.